Hi, I'm Jay from the Developer Experience team, and this is an overview of the GitLab end-to-end tests. We'll dive into the directory structure of the tests, and then I'll show you how to find your product groups end-to-end tests. We'll do a deep dive into a particular test, and then I'll show you the pipelines where the tests run. We'll debug a failure from a merge request, and then I'll give you an overview of how feature flags work with the tests. We'll then troubleshoot a failure issue and then execute the test locally against your GDK. Okay, so to give some context around end-to-end tests, they represent a real user workflow against a real running application. The workflow example on this slide is a user logging in, creating a project, creating a merge request, adding another user to the project and approving the merge request, and then setting it to merge. At GitLab, we have low-level tests. The next level down is the feature tests. In those tests, the equivalent, a similar test would be, we would use factories to set up all that data. We would navigate straight to the merge request page and merge the merge request. So there's a difference there between a full user workflow and testing a particular feature. End-to-end tests are slower and more expensive to run and maintain, so we need to keep that in mind. So if we can test functionality at a lower level, then we should do so. At GitLab, our end-to-end tests test against a full GitLab instance, and it can test against different instance types. Omnibus, GitLab.com, GDK, or Cloud Native GitLab. All we do is point to a particular URL. They're mostly browser tests, although there are some API-only tests and tests that use SSH only. They heavily use the API to set up test data, but we do ensure that we test workflows through the browser also. Underneath, they're simply RSpec tests. They use Capybara, which uses WebDriver to drive the browser. We're modeling the pages as page objects, and we're modeling GitLab domain objects as QA resources. Using the GitLab QA orchestrator, we can spin up different modules that are required in certain end-to-end tests. For example, the AI gateway or like Elasticsearch. In this section, I'll go through the major directories you'll be using when contributing to the end-to-end tests. Please remember that these directories are subject to change, but this should give you a general idea of how the end-to-end tests are structured. We'll first look into the actual test files themselves and where they're stored and how they're split up. Then I'll have a look at the GitLab domain objects where we're modeling concepts like branches and projects and groups. And then we'll look at the page objects directory where we're modeling UI pages of the GitLab application. So I'll open my IDE. The top level directory is the QA directory in the GitLab project. We have a number of support files that I will not go through at this time. But we're interested in the inner QA directory, so it's QA/QA. And then the actual specs are stored in specs, features. So we can see that this directory is split up between API, Browser UI, and EE. So we can see with the EE directory, there's also API and Browser UI. So the EE directory is for tests that are designed to run against a GitLab instance with an enterprise license, whereas the top level tests will run against GitLab free tier. Within the test directories, we can see they're modeled by stages. So for example, we have the plan stage and the create stage, for example. Opening that, sometimes the directories are modeled based upon different GitLab concepts like merge requests and repositories. And within there, we can see some further organization and some of the actual test files themselves. So looking at resources, so here we're modeling GitLab domain objects. So we can see here's a file. So in this class, we're able to create a file, get the file, delete the file. And we've modeled all the objects in GitLab that we need for the end-to-end tests. And then we have the page directory, which is where we've modeled the actual page objects. So if we take a look at issuables, new, so this is where we create a new issue, and we can see there's familiar methods like choosing milestone or filling in the description of the issue. This is not all the directories you'll be using, but they're the major ones in this end-to-end test overview. Here's a couple of ways to find end-to-end tests that belong to your product group. The tests are in 4 separate buckets: Browser UI, API, and then the same again for the Enterprise Edition tests in the EE directory. Within these directories, there will be a directory for every stage that has end-to-end tests. I'll also show you how to search via metadata. So in my IDE, in the QA directory, in specs, features, we can see in Browser UI, we've got a list of stages that have end-to-end tests. In Verify, they're logically separated. I'll open one up. So we can see the pipeline execution stage has their specs here. Likewise, we can use this same product metadata to find tests. So if I want to see all code review end-to-end specs, I can search for the product group metadata. Here we have the cherry picking and merge request test. Okay, now let's take a deep dive into an end-to-end test. We're going to look at the test structure and how we create domain objects using factories. We'll look at how we interact with pages and use data test IDs to find elements. We'll also look at how assertions work in the end-to-end test framework and some of the test metadata that may be useful to you. I'll also speak about orchestrated tests and how they fit into the framework. Okay, here we have an end-to-end test that adds a GitLab CI file via a template. We can see on this test that the product group that owns the test is source code. It's part of the create stage, and it's an aspect test. So the end-to-end tests are simply aspect tests. They have a describe block, they have context blocks, which make the test, which format the test in a logical manner. In the end-to-end test, the top-level describe block is currently set to the stage group. This allows us to collate reports per stage group. And then we have a describe block describing that we're testing file templates, and then the it block describing the test. Other tests will have context blocks where appropriate. In this test, we need to set up some test data as in a project. So this is how we set up a project. We use this create method, which basically links to a factory, the project factory, which links to the project domain object. So here is the factory, and that links to the QA resource project. So we'll go to the QA resource project, and it's part of the resource module. And this is where we put in methods for manipulating the domain object. So in this case, it's a project. So a project gets initialized with some properties, and then it can be fabricated. So by default, the fabrication method is fabricate via API. So back in the test, this create project will create a project with this name and this description via the API. If we explicitly say to fabricate, this will actually fabricate the project via the UI, which is important for some tests perhaps. But in general, a lot of tests need projects, so we just create them through the API. But we can see when we're testing via the UI, we have to navigate through pages, fill in text boxes before creating the object. So it would take a lot longer. So we've created a project now in our test, and that can be used within the test. We then have a before block to log in and then visit the project. and then the test case can start. So the perform method here against a domain object will actually perform an action on a page. So I'm going to take a look at the file form page, which is a page to create a file in GitLab. And we can see with that page, we are adding a custom name to the file and then selecting a template. So let's take a look at those methods. So adding a custom name, we'll take the name and then add the name to the file, which is basically filling the element in with a name. The element here is defined as file name field. This links to an element at the top of the object. And this element links to a data test ID on the page. So if we open up, I'll use the template selector for example. The template selector element is defined under this view. So if we open this file, we will see the template selector. So I'll open up the file. We can see the test data ID is defined here. So there sometimes needs to be front-end changes to allow the test to interact with the page. Next up we have the assertions. So once we've manipulated our page and submitted the form to create the file, we have some assertions. There's nothing special about these assertions, they're standard aspect assertions. I've put in a failing assertion here to demonstrate that when we submit an MR and this test fails, we can take that MR, have a look at the MR and then try and recreate the failure locally. I want to mention some of the key pieces of metadata that you'll find on the tests. So the test case metadata you will see on every test, it's a URL which links to a GitLab test case. So this is a GitLab test case, and we have automation that updates this test case with failures and results. We have a linter to make sure every test has one of those files, has one of those test case issues. Quarantine. So if a test is not working as expected, and perhaps it's a known issue that's under a fix, that's not yet to be fixed, we can place the test in quarantine. So you'll see on tests that have quarantine, they'll have a link to an issue, and that issue would generally be open, awaiting something to be done. The smoke metadata, as you can see on this test case, indicates that this test will run once a new version of GitLab is deployed to staging. So if this test fails in staging canary, it will actually block the deployment. So every test tag with smoke will run on staging canary deployments. The only metadata dictates where we can run tests. For example, this test here only runs on GitLab.com. So we've specified here with only that it only runs in the staging and production pipelines. The orchestrated metadata indicates that a test is orchestrated, as in it uses the GitLab QA gem to orchestrate a GitLab instance and another component where the test is run against the GitLab instance with that other component integrated. The GitLab QA gem, I've added a link here. So it's important to note that orchestrated tests can be run locally against your GDK. However, the extra components that GitLab QA creates have to be created previously in your environment. So if you're testing this particular test, which is orchestrated, it requires AI gateway. As long as your GDK has a configured configured AI gateway, the test, you'll be able to execute this test against your local GDK. I won't dive too far into the GitLab QA orchestrated scenarios, but it's good to be aware of the orchestrated metadata. To summarize, here's a conceptual diagram of the end-to-end test structure. So at the top level, we have the RSpec file, which represents the end-to-end test. It uses page objects to drive UI interactions. It also uses QA resources, which are GitLab domain objects, which provides the test with test data. Also, the QA resources can use the page objects themselves. For example, if you've got a project and you want to create a project via the UI, or they can use the API. Within the page object abstraction, I've just mentioned here that we use the data test ID attribute to locate elements. So this is a high-level diagram of what an end-to-end test consists of. Okay, now that we've seen an end-to-end test, where do they actually run? So importantly to product engineers, they run in MRs. So we have the test running against the GDK and CNG on every merge request, and they're blocking. So if any test fails, the merge request cannot be merged. We also have an optional run of the omnibus tests. So you can manually trigger them, or you can apply a run all end-to-end test label, and they will be automatically executed. These are not blocking due to the flakiness of the omnibus tests. The reason why they aren't run automatically is because the omnibus build takes quite a long amount of time, and that would increase the time for a merge request pipeline to be completed. The tests also run on master scheduled pipelines, and when the blocking tests fail there, that causes master broken incidents, as you're probably familiar with. We also execute the end-to-end tests on live environments, both on deployments and on a schedule. So the most important execution here is probably the staging canary smoke tests. So smoke test failures here will cause deployments to be blocked. And this is just mentioning that results are reported to Slack. There's some channels there. So if you switch a feature flag on and you want to check that the environment is still performing as expected, you can check those channels. In this section, we're going to take a look at a merge request with a failing end-to-end test. We're going to have a look at the different end-to-end test child pipelines and the different artifacts we can use to investigate the failure. These are the steps we could take before having to run the test locally to confirm that it's an issue. So I have a merge request that has an end-to-end test failure. Let's take a look at the pipeline. I prepared this earlier with an end-to-end test by changing the content of an assertion. So the pipeline has failed, and let's dig into why. In the QA section, we see the trigger jobs, which trigger the different end-to-end test child pipelines. So I've got CNG and GDK that run by default. We can see here the omnibus child pipeline hasn't been executed because it doesn't execute by default. Let's have a look at the end-to-end test pipeline that runs against the GDK. This merge request only ran one test. It only ran the test that we modified. And we modified that test to fail, so that's expected. So let's dig into the job. So the first piece of information we can look at is in the job log, the actual failed example. So this gives us the test and the file name of the failure. We can then scroll up to the exception. So this exception is saying that we haven't found the content foo in the page content. So that's the next piece of information we can use. This is pretty straightforward and we know why it's failing, but let's dig into what other resources we have at this point. We can scroll up and find the test that's failing. Here we can see the job log. So this log is actually the test log. So it gives us some information about what's happening in the test. Filling in username, filling in password, clicking this button. So that can sometimes give us some hints as to why the test is failing. If we keep scrolling up, we can see that the test is actually run twice. Automatically, the end-to-end test will retry. And in this case, it's the same test failure, so we know it's consistent. In cases where it's a flaky test, perhaps the failures can be different. The next piece of information I usually look at is in the artifacts. So we hit Browse. We're presented with all the application logs, but before diving into them, I'm going to go into the QA folder and have a look at the screenshots. So the failure screenshots. So this is our screenshot at the time of failure. When the failure occurred, we're searching for the string foo in this page and it's not there. So we expect this screenshot. We can actually view the HTML of the page at the time of failure. So that can be downloaded. Styling isn't applied, but we can still interrogate the DOM using Chrome DevTools. And that may give us an idea of an element that's missing at the time of failure. So we've seen the screenshot. If we still can't work out why it's failing, we can then look at the application logs. So we have complete application logs for the duration of the test run. Because there's so many and there's a lot of information here, I'd recommend to download all the artifacts, unzip them, and then grep for different errors. If you have an idea of where the failure is occurring, you can dig into the individual logs. We can also have a look at the Allure report. So you may recognize a comment on the merge request, posting the results of the Allure report. So we can see here, there's a report for the GDK test and the CNG test. So let's have a look at the GDK tests. We can see the test that's failing here. And this can give us some more information. It holds the screenshot as well. It holds the HTML. And we can actually view the browser log in here. So this is useful for front-end bugs, to have a look at the browser log at the time of failure. Another technique to try is just simply retrying the job. If it's a network issue or a one-off failure, you can always retry the test job to see if you have more success. And then the next step I would perform is to actually run the test locally, and I'll have a look at that in the next section. Before we go on, I just wanted to highlight feature flag functionality in end-to-end tests. So if a feature flag is added or modified within a merge request, the end-to-end tests run in two different states. One with the feature flag in the state of the merge request, and the inverse. This is to check that the end-to-end tests are passing in both states. Let's take a look at an example merge request. In this merge request, we see that your workgroups view feature flag has been created with a default enabled of false. This means this merge request will get the feature flag label. So how does this impact the pipeline? Here we can see in the GDK pipeline that there's a GDK instance set of jobs and then a GDK instance inverse set of jobs. So if we dive into one of these, I'll search the job log. We can see at the start of the job, we have successfully enabled and verified the feature flag your workgroups view. If we check the regular job, it would be disabled. Whereas in the inverse, it is enabled. So that gives us coverage across both states. If you're changing functionality without changing a feature flag, but you want to test that functionality against a different state, it's recommended to create a draft MR with the feature flag in the state you want to test against. There's also some metadata you can use in the end-to-end test to actually enable feature flags. Search for the feature flag metadata to see some examples. These tests would require admin because only an admin can switch on and off feature flags. It's also worth mentioning that when a feature flag is changed in an environment, such as staging, a full test run is executed. You'll be given, whoever changes the state of the feature flag will be notified in Slack. Okay, so now I'm going to debug an end-to-end test from a failure issue. So failure issues are created when a test fails against master or a test fails against a live environment. I'm going to point out different metadata on the failure issue that can be useful in diagnosing a failure, and then we'll jump into the failure within the job, and I'll show some artifacts that can be useful. So here we have a failure issue that was created recently. The performance bar spec failed against master. I can tell it's master because we've got a found label here of main, which actually aligns to master. We have a link to the test itself in the code base. And we've got a link to the test case history. Here we can see the history of failures. So this is useful for looking up failures that have occurred in the past to see if it's a recurring issue. So back on the failure issue, we can see the stack trace for this particular failure. It looks like when we're visiting this page, we're waiting for the page to load. We can see there's a spinner here, which is still loading. So that has caused the failure. And then we have a screenshot. Then we have a list of occurrences in reports. So this has occurred twice. We can see in the metadata, it's part of the analytics instrumentation group. From there, to diagnose further, I would jump into the most recent job log. We can see the exception here and the error message. I'd also jump up and see what type of job this is. This is a CNG instance job. From there, we can check the artifacts. We can have a look at the application logs here. Or we can view the failure screenshots or the failure HTML. Failure issues can also be raised when a test fails against a live environment. Here's an example of a test failing against staging Canary. And we can see it was from the amount of occurrences that it was quite frequent. And that's something that we have quarantined. And we can see that the label has been reflected there. Okay, let's run our test locally against our GDK. In this example, I'm going to show you a few different environment variables that are helpful for running tests locally. There's quite a number of variables that can be used within tests, but I'll just go through some major ones that will help you get started. Firstly, from the GitLab project, we need to change directories into the QA directory. From there, we'll do a bundle install because the end-to-end tests have a different gem file. And then this is our command to run the tests. I'm inserting the GitLab QA admin access token, which is an access token of an admin user in my command. If you don't do this, the test will actually manually create a token, which adds extra time. So inputting this token means we can create users on the fly via the API, so it's much quicker. I always increase the log level to see the output at the debug level. I run my GDK in HTTPS mode, so you can modify that in using the QA GitLab URL. From there, it's just a simple bundle exec rspec command. We're going to run a specific test, which is the test we saw in the previous section. Okay, here I am in the GitLab directory. I'm going to change to the QA directory. Bundle install. I've already done this, so it's going to be quick. And then I will enter my test command. This is using my local GDK, so the access token isn't secret. So we get a bit more logging with the debug entries. So within that time, a user has been created via the API. We're logging in as that user. Project has been created in the background via the API. We've navigated to the project. We're creating our template file. And this is where the assertion should fail. And it will time out here, looking for a failure. So here is our output. And we can see, similar to the job logs, a screenshot is generated. So there's a screenshot. And this is our exception. And this is failing because I modified the assertion as expected. You can also enter the particular line item. So if a test file has many tests, you can actually specify the line file, which is an rspec feature. I've added some links here around running your tests against the GDK, and also a link to a page with all the information about the environment variables you can use in the end-to-end tests.